Hi, Bobby.
Hello, Chinnaga.
So, we've been working with a lot of coils, right?
Correct. Search coil, flux gate. I thought it's something else, but then finally I understood it's the couple of coils
Yeah. So, coils and
and
cores.
cores. Yes.
So, I think it's time to study something different. What do you think?
Yeah.
So, coils and cores.
Yeah.
We studied a lot. Have you heard of something called magnetoresistance sensors or magnetoresistive resistance sensors?
Individually, resistance, of course.
And
Magneto. Okay, at least magnetism we know.
right.
So what is this? Is it?
So, you'll be surprised.
Hmm.
I mean, this magnetoresistance has about a 3 billion market value in about 5 years.
Oh, really motivating.
So that means, I mean, even now.
But what is magnetoresistance?
Well, that's
a secret you're going to say.
that's a secret.
Okay.
I'd like to keep for a little bit from you before revealing. But, and see, there's also different types of this, whatever this magnetoresistance is.
Mm-hmm.
You can see we have an isotropic magnetoresistance,
Okay.
giant magnetoresistance, tunnel magnetoresistance. And in fact, there's another one which I don't think is used as much in industry as these three.
What is that?
Closer.
Oh, not heard about.
MR. Okay? But again, so I think it's more theoretical than than big.
The products are not there in the market.
Yes, as far as I know, I don't think I've seen any colossal magnetoresistance products. And if you look at the different types of applications, there are quite a few. You have angle and path measurement, obviously magnetic field measurement. It's used in thin film solar cells, biomolecular detection.
Oh,
right? 3-dimensional measurement parameters.
I heard this is also used in the hard disk and the SSDs.
Yes. So, here you have 3 very different applications, right? You have the automotive industry. So, again, these sensors are apparently
angle, position,
and you can think of many applications, right?
Even maybe to measure current.
Exactly. So, if you think about angle measurements, so many things inside a car, you need to measure the angle.
Yes.
Rotation, for example. An angle doesn't have to be just rotation.
It can be, yes.
Something like pedal position.
Yeah.
Something. So, like that. And what do you say? You talked about hard disks. Right?
Yes.
So it's also used in magnetic media. Okay. And
I heard this is this element is the reason for getting such compact hard disk at such a high speed of reading and so on.
So I was going to
I read some news.
I was going to ask you that question. I was going to ask you that. I was going to ask you. So the other application is micro and nano biomedical applications. So the key point here is micro nano biomedical application. So you talked about size, correct? Right. So from these applications, even though they are very diverse, somehow I think we can derive from this information that maybe these sensors have to be somewhat
can be smaller. Yeah.
Okay. I don't think you can use massive search coils in these kind of applications. Maybe you can. I'm not saying you cannot. But when you look at these applications, imagine having this massive coil inside the car. So maybe these sensors are small. We don't know. But let's see. Let's see what these sensors are. So you ask me, what is magnetoresistance?
Yeah.
What if I tell you we have, let's say, a material.
What is that material?
Material or a system of materials.
Okay.
Or a system of materials that has, let's say, a certain resistance. Okay. And then when you apply a magnetic field, this resistance also changes.
Oh, okay. Oh, that's why magnetoresistance.
Magnetoresistance. Right? So, if we were to define this MR, resistance, we can say it's the change in the electrical resistance
of that material.
Yes. of that material or system of materials.
Okay. As a function of the field it is exposed to.
Exactly.
Magnetic field it is exposed to.
As a function of the, he said,
magnetic field it is exposed to.
Of the magnetic field. It is exposed to. Okay. Now, if we were to write an equation for this, simply it will be maximum resistance goes up
when there is no field, or depends. Maybe
it depends. It depends. But let's say for a change in magnetic field, resistance goes up and then also down. So in that case,
so this is the maximum change that you can.
This is the maximum change in the magnetoresistance
for a given change in the magnetic field.
Yes, for a certain
change in the magnetic. Okay.
Right.
So what is the denominator? R min. Okay.
R min. Right. So the materials we are talking about here are generally in the millimeter or micrometer or even sometimes nanometer in scale or in dimension. Right. So some dimension could be in the nanometer range. It doesn't mean the whole material is in the nanometer range, but some dimension could be. Now, this kind of magnetoresistance also led to the development of what we called solid state sensors.
Okay.
Have you heard of solid state?
Solid state magnetic sensors.
Let's say solid state magnets. Yes, we are talking about magnetic sensors.
Yeah.
Solid state magnetic sensors. So what is this solid state? What does it mean, solid state?
Means maybe you can use semiconductor process to make this.
Yes, you can use a semiconductor process, right? And generally,
there is no moving part.
Exactly. There are no moving parts because we saw in our coil-based sensors, there are a lot of moving parts, right? There are no moving parts, which means it's also easier to kind of integrate into certain systems. Okay, like chips, for example. Now,
and the bandwidth also may be higher.
Bandwidth technically can be higher. Now, as we talked about before, there are three main types of this magnetoresistance: AMR or anisotropic magnetoresistance, GMR, giant magnetoresistance, and TMR, tunneling magnetoresistance.
I heard some Nobel Prize.
We're gonna come to that.
Connected to this GMR. Am I right?
Yes, you're right. Do you follow the Nobel Prize? I do.